Hi there, I'm JP Dice, and welcome into Beyond the Briefing. This is our weekly weather chat or seminar about what you need to know if you are flying IFR, VFR, you're prepping for check rides. We talk about all kinds of stuff on this weekly video series. Big weather we had this week. Man, oh man, did you notice that big, here's a weather word for you, derecho. The derecho that moved through the Midwest, Iowa, Illinois. We saw damage in Indiana. Derecho is Spanish for straight as opposed to rotating. A big area of straight line winds. Derechos can produce winds over 100 miles per hour. Even some embedded tornadoes with this particular system. Had a lot of comments from viewers, pilots, soon-to-be pilots, flight instructors, on kind of a brief on what you need to know if you're going for that private pilot check ride, in some cases even your instrument check ride. What do you need to know? How are you best prepared, at least from the weather standpoint with this? And in my opinion, there could probably be more weather on it. There's not a lot, and especially when you look at how the weather is taught, you look at some of the courses that you've taken, it's taught a little old school. So we'll visit some of those old school things and we'll put a modern spin on it too. When you're talking to your DPE, what they really want to know is your personal minimums, that you're not going to go out there and do something crazy. You're not going to go and fly into a thunderstorm. If you look at the data, I want you to think about this. You look at the data out there, and we're going to chat here just a little bit. The majority of weather-related accidents are fatal. Majority of weather-related accidents are avoidable. It's a decision process. Do we launch out in this kind of weather? Do we have good weather data? Do we understand that weather data? So just keep that in mind. Majority of weather-related aviation accidents, unfortunately, are fatal. Even think about it throughout history. Let's think about some airplane crashes that are notable, that were weather-related. Remember Richie Valens' Big Bopper, that crash in the Bonanza in the 1950s? Launched out into instrument conditions. It was snowy, terrible weather. And the pilot on that particular flight was not instrument rated. Had he been instrument rated, it still was not a good plan to fly in that kind of weather. The Patsy Cline crash in the 1960s in western Tennessee. That airplane launched out of Camden, Tennessee, crashed near Dyersburg. Terrible weather and instrument conditions, and the pilot in that case was not instrument rated. And then you had the country music singer, remember Jim Reeves? Jim Reeves in the 1960s had a Beechcraft Debonair, went into a thunderstorm around Brentwood, Tennessee. And then in recent history here, we had some low visibility, low clouds, IFR conditions in Los Angeles area, contributing factor to the Kobe Bryant crash there. So weather is a big factor in what we do. And if we get a better handle on it and how to interpret the data, we're going to be able to mitigate our risk and at least eliminate or reduce that portion of the flight risk that we do take. So important to know that weather information. So you're going for the check ride. Let's call this a private pilot check ride. I had been a meteorologist for a long time when I got my private pilot rating. And still going in there, it's like, oh my gosh, what do I need to know really about the weather here and how it pertains to flying? Number one, know what a Metar is. All right, know what a Metar is. Know the difference between a TAF and a Metar. Metar is now, a TAF is in the future. TAFs are actually forecast, it means terminal aerodrome forecast, every 6 hours, 4 times a day, for an area that is 5 miles around the airport. That's the TAF, okay? Remember, the TAF is created by a human. Somebody actually creates the TAF. It's going to be your local National Weather Service office. If you, and I'll punch this up. We'll go over here to ForeFlight. There you go. And I've pulled up the TAF, or actually I've got the Metar up for the Shelby County Airport right now. And good VFR flying day, scattered at 5,500, 10 statute miles of visibility. Remember, visibility is always given in statute miles. One of the few things in aviation that is statute miles. Visibility is always statute miles. Winds are generally out of the north, pretty much down the runway there at Shelby at 7 knots. And then you've got the temperature and the dew point. What would you want to know the temperature and the dew point? Temperature and the dew point is also handy, especially the temperature, for figuring out some performance calculations. There's your altimeter setting. What do you do if you don't have an altimeter setting there? You set it to the field elevation. And density altitude. We've talked about that before too. Density altitude is essentially the atmosphere that the airplane thinks it's flying in based on how dense the air is. So the higher the elevation of the airport, the hotter it is, the higher the density altitude, the more moisture in the air, the higher the density altitude. So today we're operating like we're at a 3,000 foot elevation. That's how that airplane is going to operate. This is based on the Metar. Where does the Metar come from, folks? Where do you think the Metar comes from? The Metar comes from either an ASOS or AWOS station. Automatic Surface Observing System, Automatic Weather Observing System. They're essentially the same thing. The difference is the ASOS stations are FAA, AWOS are usually managed by the airport. Okay, the ASOS stations are found at the larger facilities. Birmingham, for instance, Atlanta, they have ASOS stations. You get out toward Pell City or Shelby County, those are AWOS stations. So same kind of thing. Not a big deal there. They give you the same information. They give you sky conditions. They have a ceilometer, which they actually fire there's like a laser that shoots up, and if it bounces off a cloud, it gives you the ceiling, what you're looking at. And then you have the thermometer essentially, and then you have a hygrometer, and you have the wind speed, the arrow vane there for the wind speed and wind direction. So that's what you're getting with the Metar. So the Metar is now every hour. Sometimes you have a special observation, but essentially every hour is your Metar that you wait for. And you can get that in the air, you can get it on the ground, you can get it with your weather briefings and so forth. All right. So we go to the TAF, and I'm going to take my face off of here. There's the TAF. And this is actually, there's the coded one. And they're going to ask you to be able to decode that TAF. Very seldom these days do you have to decode anything. It's in plain English. Back in the day, these things were coded like this because you had to transmit this data via teletypes and things that had a limited baud rate. The data transmission capability was not there. These days it is. In some cases, you know, some of the aircraft systems, I know my Aspen Evolution system in my airplane, I'm actually getting the coded TAF in there. Then on the XM side, I'm actually getting the fully plain English version. So that's the TAF. That's created by your meteorologist there at the National Weather Service office, in this case at the Shelby County Airport. They do TAFs for all over the place around here. So look at the TAF, and there's the TAF. Say, for instance, when it wanted to fly at 8 o'clock tonight, scattered 10,000, winds 320 at 7 knots, and visibility is going to be over 6 statute miles. Then you go over here to MOS. What in the world is MOS? MOS is Model Output Statistics. Do not, folks, use this as a primary flight planning tool. This is only computer model data. It is raw. Nobody has touched it. It's whatever the computer puts out. As a meteorologist for a long, long time, I can tell you sometimes the computers are right, sometimes they're wrong. It takes the human hands, at least at this point in history, to be able to figure this stuff out. And sometimes we have challenges with it. Understand the relationship between dew point and temperature. All right, you got two things going on with the dew point and the temperature being the same. Either it is raining, all right, or it is foggy. Dew point and temperature. When those numbers are the same, that's relative humidity of 100%. So either you have fog or rain. So you look at the temperature and the dew point, they're the same, and you're going to have some visibility issues. Just keep in mind as the day progresses, as we start to heat up and there's that temperature and dew point spread, you're actually going to see the visibility improve. That fog is going to go away as we start to heat up. So we're looking at ForeFlight there. I want you to see something else. I'm going to switch over to the other video source. Anybody ever mess with this? This is 1-800-WEATHER BRIEF. I hope you do. Hope you have an account with this. You can get weather briefings also on ForeFlight. You can call the old-fashioned number, or you can do 1-800-WEATHER BRIEF right here. And this is what a weather briefing actually looks like. And what I've done, I've stuck in a plan here for my airplane, flying it from the Birmingham airport to the Cobb County Airport. That's going to be Romeo Yankee Yankee. Here's the route brief, and it's going to pull this information up. You put a time in there when you're leaving, what altitude, your speed, and all that. It's going to give you just a lot of information. So we go ahead and go to the web briefing, and it says our briefing is being prepared just like it would be if we picked up the phone and we talked to the weather briefer. There's actually an app for this too that you can put on your smart phone. There's a contractor, it's called Lidos, that is managing this now. Request is complete, and here we go. There's our little pop-up window. I'll put it in the middle. It's got our route drawn out here, and it's got all kinds of information. Convective SIGMAT. Now, convective SIGMATs are important because remember, from SIGMATs, they impact everybody. The air mats are generally, that's for the smaller folks, smaller airplanes. SIGMATs, if you're Delta or Southwest, you're paying attention to those SIGMATs, all right? So that means you have some convective activity expected. It gives you the time when that would happen and what you're expecting. And then it goes down into air mats for IFR, air mats for icing, and air mats for turbulence. Always easy to know about the air mat for icing. That's air mat Zulu. Think about Z as in freezing. Tango is for turbulence. T for turbulence. And then you have the air mat Sierra, and that's for, deals with IFR. So we have a map here it gives us, and it talks about our freezing levels. Talks about where we're going to have some high altitude turbulence. And in a future video, we're actually going to talk about turbulence. I know my wife is not a fan of flying in bumpy weather. We're actually going to get her on the program, and she's going to talk about some of her experiences and how I have learned to manage that. You're going to manage it and learn to be pretty good at managing turbulence and how to avoid it if you ever want to get your spouse or significant other back in the airplane with you again. Lots of information there, and oh my gosh, a surface analysis chart. Looks like we're watching the Weather Channel back in 1992, doesn't it? Cold fronts on there, high pressure, low pressure systems. And understand for your check ride, what is a cold front? A cold front is simply a boundary between warm and cold air. Those little barbs on there, the direction that cold air is moving. So it's a boundary between cold air and warm air. Typically along a cold front, you're going to have some level of thunderstorm activity. Not always, but many, many cases. Behind that cold front, high pressure typically builds in, and that's going to give you some nicer weather, maybe a little bit windy on the back side of that. You can see around on this map some little bitty lines there called isobars. Those are areas of equal pressure, all right? And the tighter those things are together, that means the windier it is. Typically in the summertime, we do not see these really tight pressure systems, but in the wintertime, you do. So this is a surface analysis. This is what's happening at the surface. And in fact, we've got a little cold front that's going to roll through the southeast this week. Behind it, some drier air. That's going to kill our rain chances, and we're going to be looking at a lot more pleasant weather, more flying weather, more VFR flying weather, if you like that kind of thing. All right, so that's our surface analysis. And then, and again, we're doing our weather briefing. This is our weather briefing if we were flying over from Birmingham over to Cobb County. There's our route of flight. There's the airport reporting sites, and it's going to show us we have VFR conditions in those areas. And it's going to tell us all of the Metar information for every airport that we're going to be dealing with. Also the cloud cover map. And what you do when you go to your check ride, your DPE is going to give you a trip to plan. Plan that trip and bring with you all of this weather information and be prepared to explain this to your examiner. What's going on here? Here's the surface weather. Here's where we think we're going to have cloud cover. Here's where we think we're going to have some thunderstorms. Is the trip maybe a no-go because we're just not going to be able to maintain VFR conditions? What are the METARs at area airports? Where's my get out of jail free card? If I get somewhere and it starts to cloud up, conditions deteriorate, where is my backup plan? Always have yourself a backup plan. and never feel the pressure, hey, I got to get out of here and there's a thunderstorm up here. And unless you know that you can avoid that thunderstorm completely, don't go playing chicken with a thunderstorm. Listen to me on this. Go to the NTSB reports and you will see it time and time again. Don't do that. Get yourself a radar scope. Look at that radar information before you leave. Have yourself a good source of weather information inside the airplane as well. You know, you leave and your flight planned everything and you've got everything together. Tell that examiner, hey, that's right now. When I'm in the airplane, I'm constantly going to be checking this information over and over again. So this is going to show us surface winds and precipitation, and this particular map is, this one is, obscuration. So you see this is around the mountainous areas. So there's a ton of information here. Winds aloft. And this is helpful for your flight planning. You want to look at the winds aloft to get the best tailwind if you can. And then convective outlooks, where we're going to have stormy weather, slight, general, marginal risk of severe weather, enhanced. It goes on and on. Get all of this information. I know it is like drinking from a fire hose. That is what a weather briefing looks like. And then it has the all-important NOTAMs in there. Those NOTAMs are pretty critical. You know, I'm guilty sometimes of not looking at all of them, but you need to, and I know there's actually too much information there. It's a lot of stuff, and there's probably this much that you really need. But it's going to give you information if there's lights out at towers, construction, cranes. It's also going to have information, hey, is the runway closed? And this has bitten people before. They're going somewhere, and they get there, and there's an air show going on. Or you've got the runway closed for construction. Always pay attention to those NOTAMs. Very important information there. And again, what we're looking at here on the screen, this is all from 1-800-WEATHER-BRIEF. Fantastic information. Put this in before a trip. You can also do it with ForeFlight and Garmin Pilot and some of the other things. This 1-800-WEATHER-BRIEF, as I mentioned before, they do have an app. We'll go back over to ForeFlight and we'll take it full screen here. And I'm going to go over to some of the imagery. And what you'll see a lot are these prog charts. And prog means prognostication or forecast. And we'll just take it out. Here's 48 hours in advance. So this chart right here is 48 hours from now, and it's going to show where the most rain is, the better chances of rain, and where those front positions are. And again, I want to emphasize your DPE, your examiner, is going to say, where would I more likely find bad weather? With high pressure or low pressure? With low pressure. Low pressure is that rising air. That's where you get the thunderstorm development. Think about low pressure. Hurricanes are low pressure. Tornadoes are low pressure. Low pressure is where you get bad weather. High pressure is typically very, very nice weather, okay? So that's an important graphic to look at, is the prog charts. Go out to whenever you're going to be flying and look at that specific time period. Also, the cloud cover forecast. Let's say we're flying 12 hours from now, and we're looking at the map, and it's going to show us where we have most of the cloud cover. Of course, the Northeast and up and down the Pacific coast, a lot of cloud cover there. So know the time period you're looking at, and also know that weather information. And ForeFlight is a wonderful thing. If you're flying in instrument conditions, especially as we start to get into the fall and the winter, instrument conditions, visible moisture, you might be concerned about icing, especially if your airplane, like mine, doesn't have the capability to deal with any of that. Here's a freezing level graphic, and this is, the freezing levels are pretty high. It's still summertime, but we'll say 7 hours from now. Freezing levels are way up there. I mean, you're getting up to 18,000 feet. So in the wintertime, though, that's going to be almost at the surface. So if you have visible moisture, you have a lot of cloud cover, it doesn't take much. You get 3,000-4,000 feet, and you may be in a freezing level. So don't skip out on the icing part. That is very important. And here's a turbulence chart, and it's going to show us max turbulence right here. 3-hour turbulence forecast. This is Sunday afternoon, and you probably see the most turbulence showing up there in Oklahoma and Kansas. So turbulence forecast, that's helpful, especially you got passengers in the plane and they may not be a big fan of being bounced around. Of course, we always know you want a smooth flight. You know that from your flight instruction. That's going to be in the morning, and that's going to be during the late evening. Middle of the day, afternoon, especially summertime, you got a lot of those thermals, and that's a lot of air moving up and down. It's going to beat you to death unless you get up fairly high above that. And we'll go back to our satellite information here. You know, satellite does not get as much emphasis as it should. Visible satellite information, especially during the daytime, there we go. We'll take Alabama. There is nothing better than giving you a picture of the clouds from space, from 24,000 miles up, and we can tell right now we have thunderstorms around Tupelo, Yucca, Mississippi, moving into the Shoals area right there. Not radar information, but satellite information. You look at this, and the dark color, that's the ground, by the way. Beautiful weather there, and you get down into Florida, and you can see those thunderstorms starting to fire up. We could just page through these. There's Florida right there. Look at those thunderstorms. And a lot of times in Florida, just so you know, you get that sea breeze convergence right there in the middle of the state. And during the afternoon, inland is where you really start to see the thunderstorms fire up. So fantastic information there. Pirate reports too. You can get a lot of information from other pilots reporting where there's going to be turbulence. There's been a lot of turbulence in the middle of the country, also in Florida. You've got some reports of turbulence and no reports of turbulence. The little circles with the slashes, that's negative. And then you've got the little yellow areas. I'll take that full screen. And that's going to mean a light to moderate turbulence. Also, if you can find out what kind of airplane it is, they post that. If it's a big airplane and it's getting beaten around, you know, you as a smaller airplane, you're going to have a tough time. So as someone going for a check ride, know your Metars, know your TAFs, how often TAFs are issued, where the TAFs come from, how to get a weather briefing, what's low pressure, what's high pressure, limitations of in-flight radar information. If you've got ADS-B, VFR conditions across most of the country, just updated. If you've got ADS-B or you got XM, know that that information is delayed. Realize weather is very fluid. If you looked at it the night before, look at it again in the morning, look at it right before you leave, look at it in the plane, en route, because things change and you don't want to get tunnel vision on what's going on. Also, preach to that examiner. You have personal minimums. Let's say it's going to be 15-knot crosswinds, and you're really like, 8-knot crosswind is about my limit. Don't go pushing it if you don't have to. You want to get better and be able to handle a 15-knot crosswind. Get out there with your instructor on a windy day and play with it and get better at that before you venture out on by yourself. And also in IFR conditions, are you the person that goes out, it's 200 overcast, and you're going to go out in a single engine airplane and launch out into that? I'm not going to do it. You got to have your limitations on that as well. Can you legally do it? Absolutely. There's a lot of things you can legally do in instrument conditions that are not wise. So remember that. Legal but not wise. Of course, if you're VFR, we're not even talking to you. You stay out of the clouds. Not a good plan. So lots of information there, and we'll take there's a radar look right here, and these are just some static radar looks. This is what we call the old radar summary page. Remember this? You used to print out on a die-fax chart. Now it's color-coded. This is sort of handy. It's old data by the time you look at it, all right? But it does give you the idea on the tops. 47,000 foot top, 53,000 foot top. So you know, even if you're in a Gulf Stream, some of these you're not going to be able to get on top of. Look at some of those in Florida, 53,000 foot tops there. And by the way, you see these little circles? That's not little blotches of rain in South Carolina, Georgia, and Alabama. That's around radar sites. That's ground returns. Anytime you see those little circles. Sometimes you can even pick up birds coming off their roost by looking at radar information. So, hope this helps you out with your private pilot check ride. Just understand this weather information, have a good flight plan, a good weather briefing, have yourself some alternates in case the weather did get bad, where you're going to go, and just understand the pressure systems, where you're going to have the windiest areas on the map, understand how to decode a Metar, and what air mets and sigmets are, and convective sigmets, where all this information comes from, and you'll do just fine on the weather section of your private pilot check ride. Hopefully you find this helpful. Good luck, fly safe, and watch the weather. I'm JP Dice. Thanks for watching Beyond the Briefing. Don't forget to like and subscribe and leave me some comments. I always love hearing from you. You have some questions for me, happy to answer those too. Anyway, be safe out there.